OK, so let's take a look at our data path here and see where predicates fit into the data path. And we're going to focus actually just on the conditional move predicate or predication instruction here. We're not going to look at full predication just yet on the data path, but it follows a similar idea. OK, so what do we need to do? What do we need to add to our sort of boring MIPS-style 5-stage pipeline to add this instruction? OK, instruction comes in, moves down the pipe. Oh, this is interesting. I know, this is a really cool trick. Let's just, if this condition is not true, let's just kill the write back to the register file. It's brilliant. We just suppress the write back. We don't have to actually change our data path at all. We just sort of put an AND gate in here. And this AND gate depends on this condition. Simple. It's easy. Maybe this is what we should do. Looks simple. We just add an AND gate where the big X is, and life is done. OK, well, that looks good. Can we bypass this value? So can we have an instruction that directly follows this move 0, or this conditional move 0, and reads RD? Well, where are we changing RD or not changing RD? Where are we making that decision? Well, in this pipeline, because we did it in the write-back stage, it doesn't happen until down here. Down here in our write-back stage, or this wire, that's the write-back wire, runs all the way back into the write enable on a register file. OK, well, that doesn't really help us a whole lot, especially if we're trying to bypass, and we're trying to bypass out of here, our ALU, back around. Because at this point, we haven't figured out any way to suppress this. So we don't actually, we're not able to actually suppress that. So what do we think about this? So how do we go about doing this? So let's think about how to actually bypass out for this conditional move instruction. Because conditional move, it's just a simple comparison with 0. We should be able to do that in one cycle. We don't really have to wait to the end of the pipe to do that. And we want to be able to bypass it into a back-to-back instruction. OK, so how do we do that? Well, our bypassing doesn't work. What if we somehow pipe forward the original value and the new value? OK, so what do I mean by this? So this instruction is very interesting. It is much more interesting than your standard like add instruction. So why is it interesting? Well, let's look at the semantics very closely here. Move 0 is going to write RS to RD, or it's going to write RD to RD. Now you say, why do I need to write RD to RD? Well, in the bypass path, when we provide this value around, back to our bypass registers or our forwarding logic here, or bypass muxes or forwarding logic, we need the old value of RD. So in a traditional some sort of RISC pipeline here, we're only going to fetch our two sources, and we only write one location. So we're going to fetch RS or RT, and then we're going to write to RD. Now, all of a sudden in this instruction, we need to read RS. OK, we need to read that because we need to overwrite RD with RS if the condition is true. And we need to read the condition RT. But aha, we may also need to read RD here. And this is because when we get to this stage here, and we want to use this bypass path to forward the value of what RD is going to be in the future, we need the original RD. So sort of to draw this a little bit more succinctly, because this is pretty important, we have if the register value of RT equals 0, we have R of RD gets RS. Okay, that's the easy one. We can count the registers here. One source, two sources, one destination. They look simple. And what everyone always forgets is there's an else case here. And what does this else case say? Well, the else case is going to say register RD gets register RD. And you might say, well, RD already had RD. That's true, but our bypassing or our forwarding logic didn't have that. So we need to actually read this RD. So that means we need to read 1, 2, 3, and we need to write one location. OK, so that's going to cause us some problems over here. Because all of a sudden, we had our register file, which had 2 read ports. And we need to now have 3 read ports. So we need to add an extra read port on our register file. And this could be expensive. So if we actually want to build predication, it's going to have some cost. We might, if we want to build predication and actually bypass something like a predicated conditional move, we're going to have to add another read port to our register file. And that actually has some costs. And this is especially costly if you look at something like a VLIW. So let's take, for example, a 3-way VLIW, something like the Tylera processor. So it's a 3-wide VLIW. Each of those ways, or each of those pipelines is going to read 2, if you don't have conditional move, we'll say. And it's going to write 1 value. So it's going to have 6 read ports and 3 write ports. So it's a 10-port register file. No, excuse me, it's a 9-port register file to begin with. And if all of a sudden we add something like conditional move here, and we need to add these extra read ports, we're going to go from a 9-port register file to a 12-port register file, where you have, let's think about this. You're going to have 3 write ports and 9 read ports. That's hard to do. It's hard to build these really heavily ported register files. OK, so to sum up here, our problems with full predication is that you need to add another port to the register file. You need to bypass the predicates. So what I mean by that is you're computing predicates, and you want to use it in the next instruction. So if we go back to this instruction sequence here, we compute these predicates, and we want to use it very carefully, or very, very quickly after it. We don't have to wait to the end of the pipeline for those predicates to be computed. So effectively is going to make it so that we're going to have a predicate register file sitting somewhere here, and we're going to have bypassing around the predicate register file, or forwarding of the predicates to get the predicates there faster, or get the predicates to be used in the next instruction. And you're going to have to add extra pipeline registers to pipe forward the old value, because you might need to keep the old value in the bypass. And in fact, actually, a lot of times when people do these things, they actually always write the register file and just pipe forward both, and at the end make the decision, or along the way they make the decision to go into the bypass or not. But then sort of when the instruction finishes, that's when they make the decision. So we're going to actually have to add more pipeline registers to pipe forward the old value that was in this case, RD.